Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Nurul Hafini binti Muhammad Fauzi. So today I will present about my review paper. The title is a review on the characterization of biodegradable packaging derived from various sources. Basically, this presentation consists of three content which are first, introduction, second, literature review, and third, conclusion and recommendation. First is background of study. According to Han et al. 2016, oxo-degradable plastic is one of conventional plastic based on petroleum that have chemical additives such as carboxylic acid and dithiocarbamate under the control of UV light or heat that accelerate biodegradation process. Professor Tony Underwood from University of Sydney said, over time, plastic will become less obvious to the naked eyes. However, the plastic still exists in smaller pieces known as microplastic. The microplastic size around 5 mm and will harmful to wildlife such as fish, crustaceans, and coral that mistaking them as food. According to CD et al. 2019, to overcome those issues, bioplastic derived from natural sources, biomass, and renewable waste such waste from banana peel, jackfruit, starch, and cellulose from plant has been introduced. So, in this study, is about to discuss in detail about bioplastic derived from fruit waste, which is jackfruit rind and jackfruit seeds, and been compared with oxo-degradable plastic in current market. The problem statement is many people start aware about plastic pollution and make decision to change to oxo-degradable plastic as solution to littering. This is because the marketing statement of environmental friendly, green and biodegradable that confusing consumer. However, oxo-degradable plastic is not appropriate for long-term reuse at scale of recycling or composting. Inappropriate landfill disposal of oxo-degradable plastic will cause the greenhouse gas release and resulting in the global warming. Nevertheless, oxo-degradable exhibit many drawbacks to the environment. People still use until today due its properties such as inexpensive, simple to manipulate, and easy to shape into various products. So, to confirm oxo-degradable in current market is safe for environment and living creatures, it must to characterize the commercial oxo-degradable plastic in market and compare it with bioplastic derived from different parts of jackfruit. The significance of this study is, this study will provide the information regarding properties of commercial oxo-degradable plastic. The properties of this commercial oxo-degradable have been compared with bioplastic produced from jackfruit seed and rind. Therefore, in future, this information is useful and the bioplastic derived from the jackfruit can be used to replace commercial oxo-degradable plastic. There are three objectives of this study. First is to review properties bioplastic derived from jackfruit rind and jackfruit seed. Second is to evaluate the properties of various commercial oxo-degradable plastic by using FTIR analysis, tensile test, biodegradability test, water vapor permeability test, and solubility test. And third is to evaluate the properties of bioplastic derived from jackfruit rind and seed by using FTIR analysis, tensile test, biodegradability test, water vapor permeability test, and solubility test. Next is bioplastic. Bioplastic are biodegradable plastic that produced by a variety of microorganisms and from renewable resources such as maize, sugar, potatoes instead of fossil fuel. There are four types of bioplastic which are photodegradable plastic, bio-based plastic, compostable plastic, and biodegradable plastic. Researchers have been developed plastic spectrum as shown in the figure 1 to make sure consumers make the best decision on choosing their packaging. As we see at the figure 1, at the right of the arrow is a bio-based plastic which is the most preferred packaging to use. Next is advantage and disadvantage of bioplastic. So first we will go through on the advantage of bioplastic. Bioplastic is derived from renewable resources. It is more environmentally friendly and more energy efficient. Bioplastic can reduce the carbon footprint, which means it can reduce the greenhouse gas emission, and it is quickly degrade and decompose. For the disadvantage of bioplastic, it needs a higher cost of production. It will increase the competition of land area for the production of food, and if the inappropriate handling bioplastic waste, of course, will lead to the pollution of soil and water too. Next is oxo-degradable plastic. Oxo-degradable plastic are traditional polymer in which chemicals are applied under the action of ultraviolet light or heat and oxygen to increase oxidation and fragmentation of the material. Oxo-degradable plastic will be degraded until smaller pieces that known as microplastic and will release into the marine ecosystem and join the food chain and end up being eaten by humans. As the figure shown at the left side, shown how the microplastic enter the marine ecosystem and affecting them, and figure at the right side shown the microplastic that found in the fish belly. Next, we will move on the analysis of the film. First, we will go through on the tensile strength. For the jackfruit seed starch bioplastic, according to Santana et al. 2018, the percentage elongation increased as the concentration of starch decreased. The stiffness of the material increased as the starch concentration increased and the glycerol concentration decreased. For the jackfruit rind cellulose bioplastic, according to Rahman et al. 2016, glycerol 40 with the gelatin 60 matrix film had the highest elongation at break but the lowest tensile strength. When the gelatin concentration increased, the Young modulus will increase because the dry mass biofilm increased, as the thickness and mechanical resistance of the bioplastic also increased. For oxo-degradable plastic, according to Sochil et al. 2021, the elongation at break is not proportional to the length of the plastic chain. Even a heavily weighted embryonic plastic has a molecular weight in the 10 of 1000 gram per mole. For the analysis on water vapor permeability for the jackfruit seed starch bioplastic, according to Santana et al. 2018, the concentration of glycerol and starch increased, the concentration of water vapor permeability also increased. For the oxo-degradable plastic, according to Gibbons and Rickert 2018, the additive lead to change in water vapor permeability where the barrier properties of the film decrease with additive content in the polyethylene matrix. Analysis on the solubility of film. For jackfruit seed starch bioplastic, the solubility is around 16.42% until 23.26%. The solubility of film increased continuously as the starch concentration on the film increased. For the jackfruit rind cellulose bioplastic, the percentage of film solubility reduced from 97.97% to 71.28%, while for oxo-degradable plastic is a lower in water solubility. It will soluble in certain organic solvent, but when cross-link happen, it will become insoluble and swell in the liquid without dissolve. Next is analysis on biodegradability of film. For the jackfruit seed starch bioplastic, the initial weight of film is 0.25 gram. After 14th day, at soil surface, the weight loss of film around 95%, in the soil is 100%. The technique of burying in the soil allow bioplastic degrade faster than at surface soil might be related to microorganism activity that are buried in the soil. For the jackfruit rind cellulose bioplastic, the weight loss of film that contain cellulose was accelerated because the film produced was extremely sensitive to moisture and also to soil nutrients. For oxo-degradable plastic, in the soil at 60 degrees Celsius, degradation of the material of 60 to 65% in 200 days. Another study from Jacobowitz at 2011, 3 samples were examined and the mean biodegradation at 733 days was calculated to be 91%. For the conclusion, oxo-degradable additive film shows more disadvantage when compared with biofilm without additive. Therefore, bioplastic is a good idea that will provide sustainable and environmentally friendly alternative to plastic pollution. Furthermore, increase research through industry collaboration and encourage the large-scale production of bioplastic are required to reduce plastic pollution in environment. Lastly, for the recommendation, it is better to describe or state clearly label on the food or material packaging and the appropriate ways to dispose the packaging to avoid improper dumping of bioplastic. The studies on jackfruit cellulose and starch film also needed to improve in terms of their characteristics and properties in order to make it the best option to replace oxo-degradable plastic. So the uses of bioplastic should not be determined only by their cost, but by their performance to decrease the pollution in our environment. That's all from me. Thank you.